slower than when the passenger will reach the platform, it will be exactly at 9 hours. Okay, means here is lack of synchronization is there, that passenger plans that he will reach the platform at 1 minute to pass of the train, but his watch is not synchronized with the platform clock. Then his situation will be like this. This is case of lack of synchronization. The platform clock and the watch of the passenger are not synchronized. It is 1 minute delayed. So this situation happens in our telecom setup when network is not synchronized and we are trying to make a call. The call does not get matured, and when you are trying to connect a network, you will get a sound of 222 and call may be dropped. So call cannot be connected when synchronization is lost or synchronization is somewhat disturbed. Now second scenario, let the clock is 2 minutes slower, means the passenger will reach the platform upon the departure of the train. The situation will be like this. He can see the train is going, means in that scenario we would not be able to connect the call. So we have seen two cases of the lack of synchronization. One where the call cannot be matured, but we got the signal. And second case, even signals are not available. And third scenario, when our network is synchronized, properly synchronized, then this is the case. Then we got the proper train. The passenger is able to catch the train. So these three scenarios are there. So this synchronization is very much essential. If the connection of our equipment with the master clock is lost, there will be deterioration in the quality of the service. So SDH technology ensures that all different type of traffic, landline traffic, broadband or mobile traffic, or that is coming from different parts, different systems, are synchronized when they are being merged or when they are aggregated at the level of SDH. This point is clear. Now, next, what was the need for SDH? Another need. One was synchronization. Another is this. In the slide, you can see here three hierarchies. It is written as European, American, and Japanese. SDH was implemented in around 1990. Before that, in different parts of the world, different telecom standards or hierarchies were being prevalent. Europe was working on some different standards. America and Japan was working on some different standards. So this problem of interworking between different parts. When a packet from Europe that is having size of 560 Mbps arrives in America, there is no such telecom standards exist. So we have to install some interfacing devices. That causes the delay, more number of hardware. So the problem was lack of global standard. Before SDH, no global standard was there. So for the interconnection between different, different countries and different parts of the world, some interfacing devices were installed that were causing some delay. So at the implementation of SDH, after implementation, all countries start working on one global standard. So this problem of different hierarchies in different parts of the world was also solved. We need a global standard. This point is you are getting what I am trying to convey. Please let me know if any doubt you are having, or one point we have covered till now, synchronization. Second, that we are discussing about different standards for working in different parts of the world. This point is clear?
Yes, sir.
है ना? अगर कहीं भी doubt है It's a you can understand in Hindi also if I am using Hindi. It's okay
Yes,
with
sir.
you? Okay. ठीक है. तो अभी कहीं पर भी आपको यह समझ में नहीं आए तो आप मुझे बताइए, है ना. तो सेकेंड पॉइंट दैट वी आर डिस्कसिंग इन दैट before SDH, different standards or hierarchy were prevalent in different part of the world. So after implementation of SDH, this problem was also solved. So this was the second reason for implementation of SDH. Third thing that we can see here, the maximum capacity that can be achieved by this hierarchy was in Europe, they can go up to 565 Mbps. In Japan, they go up to 400 Mbps. In America, 274, means a capacity constraint was there. But since we are moving from voice to the data and then video, means our data consumption is growing. This was the case of more before 1990. So we need some standard that some technology that is having higher capacity. The SDS technology was designed for high capacity networks. So SDS can cater up to 40 Gbps, 40 gigabit per second. Now even we are having capacity more than SDH. In the case of DWDM, we are going up to 400 Gbps more than that. But DWDM is higher than this SD standards, means at the city level, aggregation takes place on SDH. So DWDM we can discuss after that. So another advantage that we can get by implementation of SDH was a rise in the capacity, because in these hierarchies systems were known as PDH. Before SDH, technology was known as PDH, Plesio-Chronos digital hierarchy, means no concept of master clock. But since the capacity requirement was less at that time, it was manageable. But after 1990, demand was increasing. So the all different hierarchy was combined to make a global standard. So this we have got three regions why SDH was implemented. Now next, in this diagram, this was the way of implementation before SDH. Here you can see multi-stage dropping arrangement, or we can say multi-stage multiplexing, means smaller lines, means you can see 2 obligate, means stream of 2 Mbps, 4 stream of 2 Mbps are coming, they are multiplexed to get output of 8 Mbps here. Then 4 stream of 8 Mbps multiplexed output of 34. Here it is more than 8, basically 8.448. So this was before SDH. Your traffic was being multiplexed stage by stage. So we have to install a number of multiplexers for generating a larger packet. So these